In this example, we're going to take the graphics drawing to a new level. We want to be able to actually draw the shapes rather than just send text out to the console. In order to demonstrate this, let me first run the program to show you what the output looks like, and then we'll explain how it does its work. As you can see from the UML diagram, the code has changed quite a bit. I have a interface here called Drawable, and interfaces are similar to classes because they're also a data type, but an interface can be implemented by multiple other classes, and it can make data structures and other kinds of code writing more generic and more useful. So we have our familiar classes here, point, line, and fancy line, and I've gone back to the original implementation where we used inheritance between point, line, and fancy line. You can also see some composition is there as well because there's a second point in a line and a fancy line shown there overlapping the inheritance arrows. And then we have our typical composition shown by these red associations here. And then the blue lines show classes that implement the drawable interface. We'll describe more on that later, but every class in here, except the one that contains main, every class of a shape, a circle, cylinder, point, line, fancy line, all implement the drawable interface, which means that all of these classes will implement the same named method, named draw, that allows the main program to draw these shapes independently. So let's take a look at the source code now to see how some of this works. Scrolling to the top, first I import a number of additional libraries, and that's necessary to make drawing on a canvas possible. Let's run the program. And here you can see the output, and we're actually drawing a line that's solid, a dashed line here, a dotted line, a circle, and a cylinder using circles. Now, the pen graphics, or brush graphics as it's sometimes called, uses a relative point 0, 0 to be the upper left-hand corner of the frame. And we can see that this title bar fits in and slides over the top of that. So we are locating our origin somewhere up in about this area here. So we can adjust for that later, but basically we want to get the ideas across as to how these objects actually draw themselves. That's the key to the drawable interface. Interface is a key word in Java, and an interface is just a set of variable or method declarations only. Notice here on line 17, I declare a method named draw. It's public and void. It takes a graphics argument type G, and that's going to come from the system. Java will give us that object that will let us draw on the frame. And we have a semicolon here because we're not going to define the draw method here. We only declare it. Each class that implements the drawable interface will then implement a method with this name and signature. It'll be called draw, it'll be public and void, and it will take a graphics argument as a parameter. So now as we look through our classes, when we go to class point, it implements the drawable interface, and its draw method is the last method down here in the class at line 45. A graphics object is quite useful. You can do simple pen or brush graphics with a graphics object, and there are methods like draw line and draw oval, and we'll be taking advantage of those. So when we wish to draw a point, we'll tell the graphics object that we have draw an oval using our x and y coordinates. The private instance variables x and y here are being used in the drawing behavior. So a lot of the draw methods have you specify the upper left-hand corner and the size of the region that you wish to draw. So this just says draw an oval starting 1 point to the left and above our current XY position, and draw a 1 by 1 oval, a unit-sized oval. Those are all described in the Java docs, so read the graphics class description in the Java docs to get an idea of all the different drawing behaviors. In fact, I can bring up another window here with some of that API information shown here, getting it to fit on the screen. Class graphics is quite a large class. And its methods are starting here. All the different draw methods. Draw a 3D rectangle, draw an arch, draw characters, draw an image from an image file. This one's overloaded many different ways. You can see the overloading going on with all these methods. Here's some of the ones I've used: draw oval or polygon or rectangle and so forth. So all of these draw behaviors are predefined in the library on the graphics class. The rest of the features of the point class are just as before. Two different constructors. I added a couple of getter methods that simply get the x coordinate or y coordinate. Those will be called from some of the other classes that need point data. And we still have our toString implemented so that we can send these objects to the console as well, like we've done here on a previous run, so we can see if everything looks sensible with our output. Class line extends point and implements the drawable interface. Classes in Java can only extend one parent class. Classes can only have one parent via inheritance, but they can implement multiple interfaces. So that gives the flexibility to how the behaviors are implemented. So class line can do both inheritance and implement an interface at the same time. It has one start point by inheritance and an end point here by composition. We have our two constructors again, built on their parent class for line, the same toString method as before, and a new draw method that's going to draw a line right from the graphics library. And so we get the x and y coordinates for the first two parameters of the starting point for drawing, and we get the endpoints x and y coordinates for the endpoint for drawing the line. Class Fancy Line is going to have the most complex drawing behavior. That's where I needed another library element called a general path element. I don't want to focus on that because it's quite involved, but that's why it's a fancy line. It takes a lot to draw a fancy line. Now the things that are pretty much unchanged from before, we have two constructors, one that takes 6 arguments and initializes the line sub-object first, and then it initializes the width and the draw type. And then I had to add another instance variable here for fancy lines called the draw path. And the draw path is how we're going to sketch out a dashed line or a dotted line. It's of type general path, which comes from the Graphics 2D library. Let's not worry about those details for now. We also have this overloaded constructor of fancy line that takes 2 points, a width of pixels, and a string that describes its draw type. And we still have the toString method before. And basically the draw method is the longest method here in this example. And it's going to look at the draw type field with an if-else-if structure. So if the draw type is a dashed line, here's the code that draws a dashed line. If it's a dotted line, here's the code that's going to draw a dotted line. And if it's neither dashed or dotted, we'll just call our parent class line and just draw a regular solid line. In order to make these changes, I have to change the draw stroke, and so I save away the old stroke here on line 105. Then if it's one of these fancy lines, I change the draw stroke so when it does the draw behavior, it'll come out as dashed or dotted at these points. But once I'm done, I have to set the old stroke back so that we're back to drawing solid lines again. Class Circle also implements the drawable interface. All the other details are unchanged from before. I added a couple of getters, get center to return the center point, and get radius to return those two properties. And then I added another draw method here that uses the graphics draw oval method, and that needs an x and a y coordinate and a width and a height for the oval to draw. So I simply supply that data computed from our private instance data to draw the oval. Then lastly, class cylinder is largely unchanged from before as well. It's using composition here for the base and the height. I've added another circle at the top. So we have two circles, one at the bottom, one at the top, and those need to be initialized. We have a constructor here that creates the base circle from the argument and then computes where the top ought to be by adding in the height to the center points x and y data to form a new top circle, which will be the top of the cylinder. And then getting to the end here, I haven't finished the draw method, but the draw method is quite simple. We tell the base circle to draw itself and then tell the top to draw itself. And later on, we can add code that will draw those two tangential lines between the bottom and top circles that form the cylinder.